So here we are, we're thinking about finding the area of parallelograms and trapezoids and kind of seeing the connections we can make about strategies for both. So when we think about a parallelogram, here's one here, for instance, up here. And as we look at this parallelogram, a couple things we can notice, right? We've been kind of thinking about it like a rectangle that went through a windstorm. You can also think about finding familiar shapes. So if I were to pretend like that's a perfectly straight line. I'm dropping from this vertex and intersecting perpendicularly to the base at a 90-degree angle. I now have, that's 90 degree, that's supposed to be a little chair. I now have created this triangle. So if you kind of imagine this triangle, I can kind of flip it right over here. So I can move this same exact triangle with the same exact area right over here. And you can see it still has that 90-degree angle. And when we do that, if we can kind of imagine we've, moved this, we'll just cover it up a little bit so you can still kind of tell it was there. But now we have this shape and it looks, holy moly, like a rectangle, right? So this is another sort of proof as to why area of a rectangle and area of a parallelogram are essentially the same. So you can think about taking this specific parallelogram here with a height of 4 and a base of 6, and you can see that we essentially moved this triangle boop, over here to create this bigger rectangle shape. To find the area, we're going to do our base, which is 6 centimeters, and we're going to multiply that by our height, which is 4 centimeters, giving us a total area of 24 centimeters squared because we multiplied two dimensions together in order to find the area of this space right inside of really the whole parallelogram here. Boop, boop, parallelogram. Okay, so we're going to use kind of a similar technique down here on a trapezoid. And poof, magically, a trapezoid has appeared. It has a base of 8 centimeters. It has a second base or the top of 4 centimeters and a height of 5. So all those are given to us. And when we use that information and we kind of use the same strategy we're using on our parallelogram, we can almost find a familiar shape and then flip it, right? Or use familiar shapes, use shapes to create other familiar shapes. So here we're going to take this same rhombus, if you will, and we're going to imagine that we kind of take it. This will become a base of 4, just like up here, and this will become a base of 8, just like down here, and then we will connect it with our side link there, and it's going to have a height of 5. Okay, so we've mimicked, it's not drawn perfectly, so it's a little bit skewed, but we've mimicked this same trapezoid. We just doubled it, we rotated it or flipped it upside down, and now what we've created is this bigger shape, right? We've created this shape here of a parallelogram. And just like up above, we know that a parallelogram has this connection to a rectangle. So if we look down here to how to find the area, here's this area of a trapezoid. You can look here at the formula. You're going to do the area of, or sorry, you're going to do the base 1, which in this case, right, is our 8, plus our base 2. Because you can see when we've created it into a trapezoid, or sorry, into a parallelogram with 2 trapezoids, we're going to put both bases together. So 8 plus 4 is 12, and we're going to go ahead and multiply that by our height, which is 5. So 12 times 5 gets us 60, and that gets you the area of the entire parallelogram. But we don't want the whole parallelogram, we just want half, because we want this specific portion before we doubled it to get the parallelogram. We want just this specific piece of this trapezoid. So we're going to end up dividing it in half. And so we know that the area of this trapezoid here is 30 centimeters squared. We've multiplied 2 dimensions, a base and a height together.